Hi, this is the first video of my A-level maths integration video series. In this video, I will be explaining all of A-level year 1 integration techniques along with examples. I've also attached a cheat sheet, the link of which can be found in the description below. If you find these videos helpful, please make sure that you like and subscribe so you don't miss any lesson. I will be uploading regular A-level maths and GCSE maths content. Let's start with year 1 integration. Integration is the opposite of differentiation. Now what that means is, if I say that dy by dx is a function of x, and if I were to integrate this is the integral sign and I put it on both sides, so then because they're opposites of each other, this will just lead you to y. So therefore, I can say that the integral of f of x is y. And I'm going to put a dx here as well, which means that I'm integrating with respect to x. Let's look at the formula for integration. How do you integrate x power n? Integration, as established, is the opposite of differentiation. So what we do is, when we differentiate x power n, what do? We bring the power down, and then we take 1 away from the power. Because integration is the opposite, what we would do in integration is we would add 1 to the power first, and then instead of multiplying with the power, we divide it, but make sure that you divide it by n plus 1 and not just n. We're going to talk about indefinite integrals now. When you have to differentiate, for example, if y is, let's say, 2x squared plus 4, and you differentiate it, you get 4x, that's it. This 4 is a constant, so becomes a 0. So if you were now to integrate this, how would you integrate? X is the power of 1, so I'm going to add 1 plus 1, and I'm going to divide by the new power. This will give me 2x squared. So when I integrated this, I did get 2x squared, but I did not get the plus 4. That is because constants, when you differentiate, become 0. Therefore, we don't know what the value of the constant is. So whenever you integrate an indefinite integral, you will always add a plus c, which denotes that there is a constant value there. Now, with indefinite integrals, you can also have polynomials. Polynomials is more than one term, as you saw here. So if you have, let's say, x power m plus x power n, and n and m can be any values, numerical values here. If you have to integrate them, if there is a plus sign in between, not a multiplication, you can integrate them individually. For instance, if I have 3x squared plus 5x and I have to integrate this, I can integrate them individually like this. Another thing you can do is, if you've got a constant here, which is 3 in the first case and 5 in the second case, you can put them outside if you want to. I will show you both ways in which you do it by taking them outside, and then one which you don't take them outside and you get the same result. So when you integrate it, you get 2 plus 1 and then divided by the new power, which is 3. I've integrated it already, so I'm going to remove the integral sign. And the same thing for here, for 5 as well, for x. So x is 1 plus 1 and then divide by the new power 2. So you get, these would cancel out, you get x cubed plus 5 over 2x squared. What you could have done is here, you could have another way to go about it. You do not take these numbers out like I did, and you'd still get the same answer. So I'm going to do it this way here. So now doing the same thing, 2 plus 1, that's divided by 3, plus 5x, 1 plus 1, the power is 2, so divided by 2. And you still get the same answer. Let's look at a question now. So the derivative of f, or dy by dx, is given as 5 over x squared plus 2x. And they want you to find the equation of y, and they've also given you a point that it passes through 5 and 4. So when you have dy by dx and you're trying to find y, as we established earlier, what you need to do is you need to integrate it, because when you integrate dy by dx, you get y. Now I'm going to integrate both of these individually. So 5 over x squared, that means I'm going to bring x up here and the power is going to become minus 2 and then 2x. And let's integrate them individually now. So 5x minus 2 plus 1 divided by that new power, which is minus 1, plus 2 times x has a power of 1, so 1 plus 1, which is 2, so divided by 2 here. And when you divide 5 by minus 1, it just gives you minus 5, minus 5x to the power of minus 1 plus x squared. Now this is an indefinite integral, so I am going to add a plus c in both of these steps. And I'm going to take x to the power of minus 1 downstairs again to make it positive. Now this might look like the complete equation, but I do have a constant c. And the question asks me for an equation, and it doesn't mention c anywhere. So I need to get rid of this c. You have these points, this point given when x is 5, y is 4. If you plug that into this equation, you can plug y and x's, and the only unknown you will be left with will be c. And that's how you find c. So in place of y, I'm going to write 4, and in place of x, I'm going to write 5. That's 5 squared plus c. 4 equals to minus 1 plus 25 plus c, that's 24. Take away 24 on both sides, c gives you minus 20. So the equation now becomes y equals to minus 5 over x plus x squared minus 20. Whenever you have to find c with an indefinite integral, you would have a point given that you can plug in to find c. We're now going to talk about definite integrals. So unlike indefinite integrals, we're not going to add the plus c here. And that is because we will always have a limit given. Limit is values written by this integral sign. I'm just calling them a and b here, and they can be any numerical value. A is the lower limit and b is the upper limit. Now, what do I mean when I say apply the limits? Let's say if you've got a function of x that you integrate, and when you integrate it, it becomes a new function. Let's call that function g of x. Once you've integrated it, you're going to apply the limits. And by applying the limits, I mean upper limit take away the lower limit. So you're going to plug in the upper limit first into the integrated function and then take away the same thing by plugging in the lower limit into the integrated function. Let's look at an example here. Let's say that you've got an expression x squared plus 2 and you have to integrate it, and the limits are 1 to 3. We're going to do the same thing we've been doing so far, integrate them individually. X 2 plus 1 divided by the new power, which is 3. 2, if you don't see an x written with it, that means x has a power of 0, because anything raised to the power 0 is 1. So now you're going to do 0 plus 1, which is 1, so divided by 1. This gives you 1 over 3x cubed plus 2x. Now notice how I have not added the c. That is because we have a limit. So this is a definite integral. What I'm now going to do is I'm going to apply the limits. So upper limit, take away the lower limit. So I'm going to plug in x as 3 first, because that is going to be my upper limit, and then take away the lower limit. So the same expression, I'm substituting the upper limit first, and then I'm substituting the lower limit. 3 cubed is 27, divided by 3 is 9. 9 plus 6 gives you 15, minus 1 over 3 plus 2. 1 over 3 plus 2 gives you 7 over 3. And 15 take away 7 over 3 will give you 38 over 3. And that is your answer. When you integrate a definite integral, what you're basically doing is you're finding the area between the x-axis and the graph of the function. For example, if you have a graph of a function like this, and let's say this is a graph of f of x, and you integrate f of x with respect with the limit of a to b, and let's say this is a and this is b, what you're essentially doing is you're finding the area between this, between the graph and the x-axis bounded by the limits. Let's look at an example. Here, you have the graph of a function y equals to 2x squared minus 17x plus 40x, and you have a region bounded by the curve and the x-axis with the limits 0 to 4. So what I'm going to do is, if I integrate this with the limits of 0 to 4, I am determining or calculating the area which is labeled R. So let's integrate it how we've been integrating everything so far. 2x3 plus 1, that is 4, so divided by 4, minus 17x squared, so that's 2 plus 1, which is 3, so divided by 3, plus 40, x has a power of 1, so 1 plus 1, that's 2, divided by 2, and this gives me 1 over 2x power 4 minus 17 over 3x cubed plus 20x squared. Now I'm going to apply the limits on this 0 to 4 because this is a definite integral. I'm not going to add a plus c. So when I do that, 1 over 2 in place of x, I'm going to write 4 minus 17 over 3, 4 cubed minus 24 squared. This is the upper limit. Now I'm not showing the lower limit here because when you plug in 0 in place of x, the entire thing would become 0. So let's simplify this. This will be 128, take away 1088 divided by 3 plus 320. And when you simplify this, you get 256 over 3, which is the area bounded by this region. We're now going to look at a special case where the region that you're trying to find is under the x-axis and it is not between the x-axis and the graph. So if the value of x is 5 here and I draw a line here and I integrate this function with limits 0 to 5, what I'm essentially finding is this area. Because if you remember correctly, when I integrate with limits, I find the area between the graph and the x-axis. And the region that I've marked with blue is the region that is between the x-axis and the graph. So how do I go from that to the region that's marked? If you look clearly, you have a trapezium here with lengths. This length is minus 13, so this is 13. This length given in the question missing here is 23. So this bit is 23. And the height of this trapezium, which is the horizontal distance or the x value, which is 5. So this bit is 5. So if I find the area of the trapezium, which is half into sum of parallel sides, which are 23 and 13, times the height, which is 5. If you simplify this, this will give you 36 times 5 divided by 2, which will give you 90. So now if I find the region that I've marked with blue by integrating this expression or this equation, or function with the limits 0 and 5, and I take it away from 90, I will get area of the shaded region. So let's quickly integrate this. When you integrate this, this will become x3 plus 1, which is 4, so divided by 4, minus 10x2 plus 1, which is 3, so divided by 3, plus 27. X has a power of 1, so 1 plus 1 gives you 2, divided by 2, minus 23 doesn't have anything, so you will write an x with it. And now you're going to apply the limits 0 to 5. So when you apply the limits on x power 4 divided by 4 minus 10x cubed divided by 3 plus 27 over 2x squared minus 23x, I'm only going to apply the upper limit here. I'm going to ignore the 0 because when you plug in 0 here, all of the values will become 0. So I'm only going to apply the upper limit. And when I do that, 5 over 4, 5 power 4 divided by 4, 10 times 4 cubed divided by 3 plus 27. Actually, sorry, this is a 5, not a 4. 5 squared divided by 2, take away 23 times 5. Now, this looks like a really big calculation, but all you need to do is just plug this into your calculator and it will give you minus 455 over 12. It's better to leave this in fraction here. Now, you might be wondering as to why is area minus, because how can area be negative? Whenever you're calculating the area and it's below the x-axis, it will always come out negative. So what you're going to do is you're only going to take the absolute value of it. That is, you're going to ignore the minus, and you'd say that the area, which is shaded here in blue, is 455 over 12. Now remember, if I take the area of this trapezium here, which is 90, and I take away the area that is marked with blue, I will get the area bound, which is R. So to find R, you would do area of trapezium, 90, minus area of the blue region, which is 455 over 12, as we just calculated. And you simplify this and you get 625 over 12, and that is your area.